Okay, it's another integral here from MIT 2022, and there's probably a lot of ways to get lost in this one, especially with the fourth power. There's different ways we can factor it. I think what I want to do, let's look at this. We could do, this is a difference of two squares, so maybe we could do 1 plus x squared times 1 minus x squared. We could keep going and factor it again because that's another difference of two squares, partial fractions. But my thing is usually avoiding it, so let's just rewrite it like this. So we have 1 plus x squared times 1 minus x squared and just an x up here. Now, in order to avoid the partial fractions, I'm going to want to create these terms here in order to create cancellation. The only thing is if we just did that and created those, one way we would do it is we'd get a 2. That's not good. Another way we do it, we have an x squared term. That's not good. So what we can do is we can leave the x and kind of just plug this in. We'll basically plug this in into this box right here and just add these. The reason for doing it like this is we can create that cancellation. The stuff in the box, this is just a 2 because the x squareds cancel. And then so I don't change it because we're multiplying by 2 here. Let's just multiply by a 1/2 out in front. And then next, what we'll do is we'll break this up into two integrals, just splitting it on this plus sign right here. So let's take a look at that. And now we get the cancellation we need right here, right? Cancel, 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 cancel. Then each of these are actually pretty easy integrals. We can just set them up for u substitutions. Like right here, if I multiply in a 2, then we have kind of a u du situation going on there. But again, we don't want to change it. Multiply another half. Over here, pretty much the same thing, but we have a minus sign, so we'll do the same kind of thing, create a -2, and then let me squeeze it in like that, doing the same kind of thing, but just preserving the minus. So in both cases, we can do u sub on the fly. If you were to do it out, you're gonna want a different variable just so that you're not confused. So like, this would be like a w, and this, with the dx, of course, would be like dw. So I think we can see what's happening. Let's just do it out really quick. So this is going to become over here minus 1/4 natural log of w, but that's just 1 minus x squared. So I'll do it all in one step like this. And then on this one, same kind of thing. Multiply that out, it's 1/4. And then this is going to be natural log absolute value. This is always positive, but I'm going to leave it. We'll leave the absolute value for now. The reason I'm leaving the absolute value is because I want to combine the natural logs, factor out 1/4. This one's always positive, but this one can be negative. So pull this together. For my final solution, we have just 1/4 natural log properties, absolute value, 1 plus x squared over 1 minus x squared. Add a plus c, and that's it. All right, there you go. Another nice integral from MIT 2022. Thanks everyone for watching. Have a good day.